require statement kicking out. If you want to try it with injected Web3 as well, we can absolutely do that too. And remember, the way to switch accounts in MetaMask is to either create account right here or just switch like this, and then we'll connect with account 2. So if I try to withdraw from this second account that didn't call the contract, and I hit withdraw now, it's going to give us gas estimation failed because the require statement is going to kick out. But again, if we switch back to account 1 and we call withdraw, MetaMask is going to pop up and it's going to allow us to withdraw. Now, obviously, there's nothing in this contract right now, so we're going to withdraw nothing, but we can still call it. It's going to do message.transfer 0. So this is great. We can now require this withdraw function is only callable by the owner. Now, what if we have a ton of contracts that want to use something like this? They require the message.sender to be some owner, or maybe it's more complicated than this. Is there an easier way to wrap our functions in some require or some other executable? Well, this is where modifiers come in. We can use a modifier to write in the definition of our function, add some parameter that allows it to only be called by our admin contract. Modifiers are used to change the behavior of functions in a declarative way. Let's create our first modifier. We'll call it modifier, which is a keyword, only owner, and we'll add this require statement in here. Require message.sender equals owner. Then after this, we just add an underscore and a semicolon. What a modifier is going to do is it's going to say, hey, before you run this function, do this require statement first, and then wherever your underscore is in the modifier, run the rest of the code. So we could also do a modifier where the underscore is up here, and then this is afterwards, but we want to run the require first. So now what we can do is we can make this function withdraw payable only owner public. And what's going to happen is before we do this transfer, we're actually going to check this modifier. We're actually going to run this require message.sender equals owner. And then, again, where this underscore is, that's where we'll add the rest of the function. So again, for speed reasons, and since we're not actually going to be interacting with the Chainlink data contract, we can go to JavaScript VM, switch to fundme, deploy, and we can call withdraw. Obviously, we can call withdraw from our account, but if we switch accounts and try to call withdraw, we're going to get an error, which is perfect, because that means our modifier is working correctly. Awesome. Now we have a fantastically succinct fundme contract here. The only thing that we're really missing is that when we withdraw from this contract, we're actually not updating our balances of people who funded this. So even after we withdraw, this is always going to be the same. So we need to go through all the funders in this mapping and reset their balances to 0. But how do we actually do that? We can't actually loop through all the keys in a mapping. When a mapping is initialized, every single key is essentially initialized. Now, we obviously can't go through every single possible key on the planet. However, what we can do is create another data structure, an array, something we're already familiar with. So let's go ahead and create a new funders array. That way we can loop through them and reset everyone's balance to 0. We'll do an address array because it's going to be an array of all the funders' addresses. We'll make it public and we'll call it funders. Now, when somebody funds a contract, what we're going to do is we're going to do funders. Now, whenever a funder funds this contract, we can go ahead and push them onto our funders array. So we can do funders.push message.sender. Now, if somebody funds multiple times, the funders array is going to be a little bit redundant, but we're going to ignore that for now. Now that we have an array of funders, when we withdraw everything, we're going to want to reset this to 0. When we withdraw everything, we want to reset everyone's balance in that mapping to 0. So we're going to do what's called a for loop. A for loop is a way to loop through a range of numbers to do something. So we're going to say for uint 256 funder index equals 0, because we want to start with the 0th index. We're going to give it a max size to go to. We're going to say the funder index has to be less than funders.length. .length is how we get the length of our array. And then we're going to say funders index plus plus. This means that we have an index variable called funder index, and it's going to start from 0. This loop is going to finish whenever funder index is greater than the length of the funders. Every time we finish a loop, we're going to add 1 to the funder index. That's what that funder index plus plus does. It adds 1 to the funder index. And every time whatever code is in this for loop executes, we're going to restart at the top. And all we're going to do in here is we're going to grab the address of the funder from our funders array. Funders. So the funder at the index in our funders array, we're going to use this as the key in our mapping. So we're going to take address to amount funded of funder, and we're going to set it equal to 0. So now our mapping is going to be all updated to people having 0 funded in there. We do have to do one more thing as well. We have to reset our funder array as well. Now there's a couple ways to do this, but a really easy way is just to set funders equal to a new array. So we can do funders equals a new blank address array. So all right, it looks like we've got everything in here we need. Right away when we deploy this, we are set as the owner. We can allow anybody to fund whatever public good that we're doing. And they have to fund it with the minimum USD value that we actually set. Whenever they fund, we'll keep track of how much they're funding and who's been funding us. We can get the price of the Ethereum that they send in the terms of USD. And we can convert it to check to see if they're sending us the right amount. We have our only owner modifier so that we're the only ones who can withdraw from the contract. And when we do withdraw everything from the contract, we reset all of the funders who have currently participated in our crowdsourcing application. Awesome. Let's see if everything works end to end. So we're going to go to FundMe. We're going to deploy it. We're going to confirm from MetaMask. And remember, if you're ever confused about what's going on or something weird is happening in your transactions or your deployments, you can always go into Etherscan and read more about your transaction and what's going on. Now that our transaction has been deployed, let's go ahead and just take inventory as what's going on. We have our owner, which is our address right here. We have the aggregator v3 interface version, which is version 3, which we can kind of ignore. We have the price of Ethereum in terms of USD with 18 decimals instead of 8. We have a function that allows us to get the conversion rate of any Ethereum amount to its US dollar equivalent. We have an array of funders, which right now starts out as empty. We have a mapping of addresses, which also right now starts out as empty. Let's go ahead and try to fund this contract. We'll use Way, just so that we're always on the same page, and we'll fund it with 0.1 Way. Remember, everything has 18 decimal places. So if we want to do 0.1, we just do 17. So we can do 1, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that'll be 0.1 Ethereum. Now we can go ahead and hit fund, and we're going to send 0.1 ETH to this contract. Great. So if we look at the 0th index of funders, we can see that indeed we have funded this contract. Let's even have our second account fund this contract. So all we got to do is switch to this contract in MetaMask. We can go ahead and put 0.1 ETH back in here for value and hit fund. Now, as you can see, we're deploying this from account 2. Let's go ahead and hit confirm. Funder at index 0 is going to be our admin, and the funder at index 1 is going to be our second account. And if we go ahead and we add this funder in here, we can see we've indeed sent 0.1 Ether with this account. If we go back to our account 1 and put this in here, we can see that that address also has 0.1 Ether. Fantastic. So let's try to be malicious. Let's try to have account number 2 actually withdraw all the funds in here. Let's hit this withdraw function. Uh-oh, the transaction has failed. We're relentlessly malicious. We want to send this transaction regardless. So even though I'm not the admin of this contract, I've gone ahead and still tried to send its withdraw. So what happens now? We can see that Remix is saying, hey, something went wrong. And again, if we look at Etherscan, we can see that there was a fail here. Since in our modifier, we didn't give a reason here, nothing shows up. But we could have always put a reason in there and something would show up. So, all right, let's go ahead back to the actual admin. And now let's try to withdraw everything. So if we hit withdraw now, we can go ahead and confirm. What should happen is everything in here should be back to 0, and this array should be back to 0 as well. And if we watch our address, we can see it literally just went from 0.4 to 0.6 because it got 0.1 from the original funding that this account put in and the 0.1 that our second account put in. So now if we look at funder 0, we can see it actually errored because it is now a brand new array and there is nothing at index 0. If we try to see how much this address now is funded, it's back down to 0. Awesome, you've now learned how to deploy a relatively simple yet effective crowdsourcing application where users can fund and an admin can withdraw those funds to go spend them on things. Now we've been working with Remix so far to start our smart contract and our Solidity development journey. Remix is an incredibly powerful what's known as a web IDE, or an integrated development environment. And in my opinion, Remix should always be the starting ground for anybody looking to start their smart contract journey, because it is a wonderfully friendly way to really show what's going on behind the scenes. And it's really easy to see everything we're doing with Ethereum, with Chainlink, and with our smart contracts. Now, it does have some limitations though. It's really hard to integrate other parts of different projects. It has some limited support for testing or custom deployments. It's a little tricky to save files locally. You need an internet connection to actually interact with it, and it doesn't have Python. So in order for us to deploy, test, and automate everything about our smart contract development cycle, we want to connect our Solidity and our smart contracts with a more traditional programming language like Python. This way, we can customize our entire development environment in any way that we like. We're first going to teach you all how to work with what's known as web3.py, which is an incredibly powerful Python package for doing everything that we want to do with smart contracts. Then once we learn some of the basics of web3.py, then we'll move on to Brownie, which is a smart contract development framework built on top of web3.py, which makes our lives even easier. However, it's still really important to learn web3.py first because this will teach you what's going on behind the scenes of Brownie. Now, for the rest of this course, I'm going to be working with Visual Studio Code, which is an incredibly powerful text editor that will give us a lot of formatting and a lot of really nice tools to work with deploying and interacting with our smart contracts. If you've already got VS Code and Python and your entire coding setup set up the way that you like it, feel free to use the timestamps in the description to skip ahead to the next section.